Hindi pa lang, no? Last time, wala yung recording, ano? Napansin ko, wala. Pero, actually, nag-record talaga ako noon. I just wonder kung bakit walang recording. Anyway, kung if you listened to the lecture last time, ano, kahit naman walang recording, walang problema. By the way, yung for the file upload part dun sa prelim, it's already complete, ano. You could just verify my comments dun sa uh, score, ano. I will just ask Ma'am Adele to combine the two, the multiple choice and the file upload score, so that she will be able to input it on Campus Plus Plus. I will ask her later. Ano? Hinintay ko lang kasi baka may ano kayo, baka meron kayong question sa score ninyo. Kaya hindi ko pa binigay sa kanya. Oh, ang tagal naman pumasok nila, 19 pa lang. We will just proceed. Ang tagal nila. Wait lang na. Parang hindi pa nag-chat yung iba. Okay? Chat. Few more minutes. Okay, tapusin lang natin yung PowerPoint last time. This was discussed already. Wait lang. I ask you to read to study the examples on the file upload. No, not file upload. dun sa new upload for BJT Part 1, ano, wait. This naman is your own module. Let's see. This is the same as the new upload, almost the same as the new upload. No? You just take a look at some of the additional examples on the new upload. Ano? The solution naman is complete. Ano? If ever you have some questions on the solutions there, then please do not hesitate to ask. Ano? Then we will proceed to uh, 9.0 of your own module. Ano? Wait lang. Last time we had the collector characteristic curve. The collector characteristic curve, you actually call that as the output, ano, characteristic curve. Pag naman base, ano, characteristic curve, this one is the input. Okay? So, if you will notice, ano, if you will notice, na, for the base curve, it looks like the curve for your PN diode, if you still remember that, na? So this is your VK, this is the knee voltage, which is also equal to, which is 0.7 volt, ano? This is VBE versus IB. When you look at the how do you call this? The transistor circuit that we had last time, ano, on the left side is the base part, and on the right side is the collector. The input part is on the left, so that is why this is your input curve. The output is near the collector, ano? So the characteristic curve is for your output. Okay? Now, here you will see that this is your beta curve, na? This is a beta versus IC, ano? So the beta or the DC current gain, ano, increases as IC increases, ano? Like here, ano? This is your IC, this is your beta. As your IC increases, beta increases as well, ano? However, when your IC increases beyond a certain value, which you can find from the data sheet, now beta begins to decrease this. Na? So this one is for room temperature. This is for higher temperature, that is at 100 degrees centigrade. Na? So we will proceed with 9.0. The next slide here is simply transistor testing, which you can do in the lab. Okay? So we will go to, hold on. Did you see my announcement on Canvas?
Opo, ma'am.
Okay. Yung quiz sa Monday?
Opo.
Okay, okay. Hold on. I forgot pala to record, no? So this is module 9. This is your own module, on Canvas. So we will have the DC analysis for your BJP. Na? So you will have all these six. What we will have today will be this 1, 2, and 3. And then on Friday, we will have 4, 5, and 6. Ano? I hope to finish all of this uh, on Wednesday, ano? Yung Wednesday next week. Okay? So, pwede siguro, what we can do is you can have your quiz on Monday. Tapos, tingnan natin, ano, kung may quiz kayo ng Monday and at the same time, magle-lecture, ano, para kasi hanggang Wednesday na lang tayo, ano, and then, you will be with Ma'am Adele na ng Friday, no? So, I'm not so sure if she will have a synchronous class on Friday next week, no? Basta ako hanggang Wednesday. So, I hope to finish everything hanggang Wednesday kasi the lesson for the whole midterm is up to number 6.
May concern po.
Yes.
Ma'am, alam ko po, wala pong pasok sa Monday.
Ay, bakit?
Feast of Saint Angelo po ata. Sabi po, non-working holiday po.
Okay. Pag walang pasok ng Monday, wait lang. Pag walang pasok ng Monday, tuloy pa rin yung lecture natin ng Wednesday. Tapos yung test, di ba pwede naman tayo mag-allot ng, saglit lang naman yon, multiple choice lang naman yon, di ba? So pwedeng mag-klase pa rin tayo ng Wednesday. Tapos mag-quiz pa rin. Pwede?
Pwede po.
Parang sad kayo. Okay. Sige. Wala pa tayo kasing quiz ano? Tingnan kong mabuti. Baka pwedeng, basta, mas importante kasi yung lecture ano? Yung quiz madali naman yon. Okay? I can ask Ma'am Adele to administer na lang it on Friday. Pwede rin yon next week. Sige. We'll proceed, ano? So, we will have the base bias and the emitter stabilized bias, ano? So, let's have first the DC operating point, na? So, the operating point, you call it as your Q point or your quiescent point, ano? That is, you're going to, what we will be solving later will be the ICQ, the IBQ, the IEQ, ano, the VCEQ, ano, those operating points of your transistor, ano. Now, the computation is still the same, ano, nagbabago lang yung formula because the circuit that you will be using, ano, for all this, iba't iba yung circuit, ano. That is the only reason na magbabago yung formula. But as I have said, you do not need to memorize all this. Itong mga formula na to. No, you do not need to memorize those. You simply derive, ano, you simply do the voltage and current equation. Okay? So for today, we will be looking at the Q point of different transistor circuits, na yung mga 6 na yon, ano. So we will have 2 today, okay? So this one, it says here, improper biasing can cause distortion in the output signal, ano. You have distortion on letter B and letter C, ano. So the letter A is linear operation, ano. That is, you can see now the amplification of the signal. Ito yung sinasabi ko sa inyo na your transistor is used as an amplifier, na. So this is your itong VDC na to, it's not this one, ha. Ito kasi yung AC. Ang VDC na tinutukoy dito is the black. Okay? So yung input mo is this, the blue, the AC, ano. So yung ginawa natin last time, that also this one, also for this, the whole PowerPoint is DC analysis. The AC analysis, you will have it during the finals with Ma'am Adelna. Okay? So, this is your amplifier symbol. Do not forget, pagka diode symbol, may guhit dito, no? That is for the cathode. For the amplifier symbol, it is simply a triangle, na? Now, in this case, there is a larger output that is already amplification, it has the same shape as the input except that the output is inverted, but it is not always like that. There is also a configuration wherein the output is amplified, like this one, larger output value, pero there is no inversion. There is also circuit for that. This one has inversion. There is another one wherein the output will have no inversion at all. So itong ganitong operation, you call this as linear operation, Kasi sabi nga dito, improper biasing can cause a distortion in the output signal. Letter B naman is the nonlinear. Letter B and letter C, Both of them are exhibiting nonlinear operation of your transistor as an amplifier, And you will see here that the output voltage is limited. Kung mapapansin mo on the positive, dito sa taas, on the positive peak, it is limited or clipped, by cut off. Pagka naman dito sa ibaba, here, this is also nonlinear operation. The output voltage is limited by saturation. You will see later, kung bakit this one is limited by saturation, na-clip dito sa ibaba, bakit ito naman ay limited by cut-off, na clip sa taas, Now, graphical analysis, consider the DC biasing circuit, ito, and the collector characteristic curve, this one. We shall see the effect of the biasing on the operating point of the transistor. Okay. You see here that there is a variable supply dito sa input supply, and you also have a variable VCC, You adjust the VBB so that your IB will be varying, And then when your IB varies, your IC varies as well, and your VCE varies also. Okay? So, itong graph na ito, nakita na ninyo ito, dun sa meeting natin last week. This is your collector characteristic curve, This is the output curve simply because you measure the output at the collector side. Okay? So, here, ito, kung makikita mo, you have different IBs, You have here an IB which is 200, and then 300, and then 400 microampere. Ang sinasabi dito, when IB increases, okay, ito, nag-i-increase yung IB. Nag-i-increase yung IB dito in such a way that we are adjusting the VBBs here so that you can come up with 200, 300, and 400. Ganyan yung gagawin ninyo sa experiment, You will be asked to vary the VBB so that you can come up with a 200 with certain values of base currents. So assuming that you are asked to vary this so that you can come up with the 200 micro and the 300 microamperes and the 400 microamperes, you will notice that your IC increases and your VCE decreases. Take a look here na. Nung ang IB natin ay 200 sa ganitong setup na, nung ang IB natin ay 200 microamperes, ang IC natin is this. IB increases, IB increases, IC increases also. In-increase na yung IB, it becomes now 300 microamperes. Or you will see here that your IC now becomes almost 30 microamperes. Kanina 20 lang eh, no? So, increase some more, increase the IB some more, you now have 400 microamperes. And then your IC now becomes 40 microamperes. Do you still remember yung sabi ko sa inyo last time, yung mga kino-compute ninyo na IC, and IE, that one is the IC wherein nagsimula na siyang maging constant, di ba? At this point, after the VK, you remember that last meeting? After the VK, the IC is almost constant na. Okay? Yun yung resulta ng mga computations that we have. Now, you will notice that yung sinasabi dito, and VCE decreases, for increase in IB, there is an increase in IC, but you will notice that your VCE decreases. Okay? So, tandaan niyo yung behavior na. Syempre, yung kabaligtaran naman, when IB decreases, IC decreases, and VCE, that is the voltage across the collector emitter, ito, increases. As VBB is adjusted up or down, or as you increase or decrease the VBB, the DC operating point of the transistor moves along the sloping straight line called the DC load line. Asan yung DC load line? Ito yon. Okay? Now, kanina, when IB was, kanina nakita nyo, when IB is equal to 200 microamperes, the IC is 20 milliamperes, you will be able to compute that actually if you know the beta, like for instance this circuit, dito the beta is 100. Okay, so for an IB of 300 microamperes, yung operating point na ito, for an IB of 300 microamperes, you can compute actually for the IC, and IC is equal to beta IB. Kung ang IB mo ay 100, then your IC will be equal to 30 milliamperes, as you can see here. Similarly, if your IB is 200 microamperes, IC is equal to beta IB, when your beta is 100, then your IC will be this. Okay? And for the last one, for 400 microamperes, your IC will be 40 milliamperes. These are different Q points. You have Q1, you have Q2, and you have Q3. You will decide which one will give you the linear operation of your transistor, di ba? For linear operation, ito yon. Dapat walang nagki-clip. Okay? Ito, non-linear operation. This is limited by cutoff. This is limited by saturation. Pag limited by cutoff, natatapyas dito sa taas, sa positive. Pagka limited by saturation, in this case, kasi ito yung output natin. Now, going back, you have here different Q points. You have the Q1, the Q2, and the Q3. This point is called your cutoff, and this is your saturation. Ito. Now, looking at this, we have here these values. You know how to compute for the IBQ, you know that it is VBB minus VBE over RB, yung topic pa natin last meeting, So, di ba dun sa last meeting, we have IB is equal to VBB minus VBE over RB. Q simply pertains to operating point or the quiescent point. Ano? So, ito yon. Okay? For this particular circuit, once you were able to compute for the IB, then that IB, for this in this instance, 300 microamperes, titingnan natin kung how are we going to draw this load line. Okay? So, you have here three different operating points. Yung, di ba, kanina natin, this one is Q1, Q2, and Q3. Okay? So, Q1, Q2, and Q3. Now, let's say, for example, we are considering this as our Q point. Now, if this is your input, so what you're going to do is you're just going to project it here. Okay? Project this kung saan tatama dito sa 400 microamperes. Ano? Kasi at 400 microamperes, your IC is 40 milliamperes na. So, etong input na ito, you project it here, or itong waveform na ito, you project it here kung saan tumama dito sa IB na ito. Okay, ito yan. And then for the negative peak, you just project and then you draw the load line. Okay? Ipo-project nyo lang na ganyan. And then you draw the load line. Okay? Ito naman, you simply extend your drawing for the IB. Okay? So, that will be the characteristic. Kung mapapansin nyo, dito naman sa baba, sa VCE. For the output. Just project it. And besides, these are the values, of the VCE that you were able to compute when IC is 400, when IB is 400 microamperes, Ito yon. When IB is 400 microamperes, your VC is 1.2. Can you see? When 300 microamperes ang IB, ang VC is 3.4. Resulta lang ito ng mga computations, yung IC is equal to beta IB, and then you can compute for the VCE, right? Negative VCC plus ICRC plus VCE equal to 0. So therefore, VCE is equal to VCC minus ICRC. That's how you compute for the VCE. Okay? Just using the formulas that you had last time. Okay? So project it down and then you draw. Okay? So you will see here, since we use this as our operating point, walang nakiklip, walang nakip dito sa mga waveforms na ito. Now, you take a look here. There will be clipping if you operate near the saturation. Let's say, for example, this is the Q point. And this is another, di ba, you have here IBs, and then you have the corresponding IC, So let's say you operate on this Q point, which is very near saturation, Ang layo niya ito. Ito yung, dito yung cutoff Nandito yung saturation, Dun sa, how do you call this? yung regions of operation of your transistor, di ba? Saturation dito, dito cut off, Okay, if you operate near the saturation, matatapyas ito dito, You take a look, you just project, and then ito naman, you project down. So, you take a look, there is a clipping on the negative. That is output voltage limited by saturation. Okay? Again, for this naman, this is your Q point. And then you will notice that the Q point that we chose is very near the cutoff. So, ang punto lang dito is do not use a Q point which is near the cutoff. Do not choose a Q point which is near the saturation. Otherwise, your transistor, your amplifier will be exhibiting nonlinear operation. So, pansinin ninyo, there will be a clipping on this portion so that when you project, ayan, clip na siya dito on the positive. So ito sakto. Ito pala exhibiting both clipping by saturation and by cutoff. Let's say, for example, the input signal is so large. O yan, input signal is so large. Sinakop na niya simula Q point hanggang dito sa saturation hanggang dito sa cutoff. So, hindi rin pwedeng ganon. Hindi kagaya dito, yan, ito sakto lang. No clipping. So, this exhibits linear operation of your amplifier. This 3 exhibits nonlinear operation of your amplifier because of the clipping on the saturation dito and the cutoff. Okay. So, the main point here is you should be able to locate, you should be able to know which Q point will be best, so that your amplifier will be linear. So this is the base bias circuit or the fixed bias circuit. So, tingnan muna natin ito, circuit recognition. How are you going to identify? Kasi ang daming bias, configurations, So, a single base resistor RB between the base terminal and the VCC, and there is no emitter resistor. Okay? This is different from, kung maalala ninyo, dun sa configuration natin last time, dun sa initial lecture, for transistor, this one is connected to a power supply here, which is the VBB, and then connected to the ground. So, eto naman, you only have one supply, that is the VCC. And this also gives you a correct biasing configuration in such a way that the base emitter is forward biased and P connected to positive, right? N, your N connected to positive. So, dito naman, the collector base is reverse bias. So, parehas pa rin, ano? So, ibig sabihin, you are using this transistor configuration as an amplifier. Ano? And you call this as the base bias. Ano? Base bias or fixed bias circuit. Ano pa yung sinasabi? Advantage, circuit simplicity. Disadvantage, it is a beta-dependent output value. Ano? So, this will be subjected to severe Q point shift. Ano? This is applied for switching circuits. Ano? This is used for switching circuits. Because as you remember, as I have said before, the very common applications of your BJT, ano-ano yon? One is your BJT as an amplifier, and the other one is your BJT as a switch. So this is the biasing technique for your switching circuit. Now, you have a lot of formulas here. You do not need to memorize those, ano? You simply, teka, paano ba to? You simply, liitan ko lang to saglit na, so that I will be able to write. Okay. You simply, write, no? The loop equation, ano? So, what you can do here is, basta yan yung mga formula natin, ano? As I have said a while ago, wag kayong sanang mag-memorize. Kasi pag nag-memorize kayo, sa dami niyan, magkakamali na kayo niyan sa bandang huli, ano? Anyway, sa kalaunan naman, automatic na yon, ano, mamememorya nyo siguro, ano? Well, walang problema kahit hindi mamemorya because you can always derive, ano? So, you can redraw if you like, ano? Or you just maintain it to be like that, ano? We can redraw for this circuit only, ano? Basta tandaan ninyo, teka, this one, the VCC, that means your VCC is connected this way. Plus, ha? Nakalagay dyan plus no? Plus VCC. Ibig sabihin, no? Burahin ko muna to ngayon para tipid tayo sa space, ano? So, sabi, plus VCC, so you will have your plus, tapos minus. O, syempre, hindi naman yan nakalutang na ganyan, ano? You should terminate it, ano? Dito sa ground. Okay? So, you can derive this formula para you do not need to memorize, ano? You can write your loop equation here. Pwede ito sa labas. Yan. And then, you can now write your, so this is your VCC. Na? Now, what will you do next? You have to write the polarities of the voltages across the resistor. Again, your resistor do not have polarity, but then the plus and the minus here simply pertains to the polarity of the voltage drop across each of the resistors. So you have here plus due to this one, minus. Your VCB, pansinin niyo yung sinasabi ko, no? VCB, na? This is plus, minus, you call this as VCB. Tinawag ko siyang VCB because C is positive. Pagka hiningisen nyo ay VBC, you simply solve for the VCB and make it negative, and that is VBC. VBE plus minus. How about this one? Plus, minus also, na? Kasi this is connected to plus. Okay. Now, since, ayan, nandyan na, no? You write now naman your currents. So, this is your IE. O, syempre, this is towards, ito, pag ganyan, ang direction, ano? So, definitely, your IB will be on this direction. Kasi, hindi naman nagbabago yun. IE is equal to IB plus IC. Ano? IC. Okay? So, you can now write your loop equation. So, simulan natin dun sa VCC, ano? Kung ako, what I'm doing is kung saan siya pumapasok, it's up to you, ano? Kung anong gusto nyo, kung saan lumalabas, ano? Yung arrow. So, negative VCC plus IB, RB. Remember, I'm writing a voltage equation. So, this is also voltage, ano? So, voltage, ano? Negative VCC plus IB/RB plus VBE equal to 0. So, therefore, IB/RB is equal to VCC minus VBE. Ano? So, therefore, your IB, paltan mo na lang ng Q, lagyan mo na lang ng Q that pertains to the operating point. Ano? So, IBQ now will be equal to VCC minus VBE all over by RB. O, kailangan bang i-memorize ito? Hindi na, no? Teka, linawan natin to. VBE. Okay? Basta marunong kayo ng circuit analysis, you will not have a problem. Na? So, we are done with that. Ano? So, yan yon. And then, on this loop, sa output, let's now write our loop equation. You will have here a negative VCC. We've been doing this before. Negative VCC plus IC RC na plus VCE equal to 0. So therefore, you just imbes na VCE, gawin mo na lang na VCEQ, ano, which pertains to yung operating point. Na? So VCEQ now will be equal to VCC, ano, minus ICRC. And then, of course, you compute for your IC using your formula beta IB. No? So, di ba, your IC is equal to beta IB. Ito. But then, you can substitute na your IB, the IBQ, this one, beta times, ang IB mo, yung sinulat natin na yon, ano, VCC minus VBE over RB. Okay? Why am I writing this? Kung mapapansin mo, nakasulat naman dito eh. Ano? Nakasulat naman dyan. Bakit ko pa sinusulat ulit? So that you do not need to memorize. Ano? Kaya isinusulat ko ulit. Ano? Napakahirap mag-memorize. Ang dami-dami niyan. Ano? Ang daming formula. Ano? Iisa pa lang ito. Iisa pa lang itong configuration na ito. No? So, in order to get the IC SAT and the VCE cut off, or the VCE off, you simply set your VCE to 0 volt so that your IC will be equal to VCC over RC. Ano yung IC na yan? IC SAT. Okay? You simply set your VCE. Hindi nyo makakalimutan kung ano yung isa-set nyo sa 0. Kasi if you remember last time, dun tayo sa collector characteristic curve, this is your VCE and this is your IC. Paano mong this one is VCE ha? Teka, saglit. VCE. Yan. Paano mo maaalala na IC versus VCE? Maaalala mo kasi ang output ay itong side na ito. O, ito input yung dito sa may base. O di ang partner niyan na current at saka current and voltage, itong VCC at saka IC. And this is the output characteristic curve, which is the collector characteristic curve. Okay? So, basta you set the VCE to 0, you will be able to get the IC sat. You set naman the IC to 0, and you will be able to get the VCE sat. VCE off, sorry. The VCE off, which is equal to VCC. Saan tayo nagbabase? Nagbabase tayo sa formula na ito. You simply set your IC to 0 and then your VCE off, VCE cutoff will be equal to VCC. Okay? Okay. So as this is a very simple example. You simply use the formula, direct substitution. O syempre, if you will be given this circuit, kung memorize mo yung formula, o di syempre, you just simply, you just plug in, these values on those formulas. Kanya lang may problema talaga kasi doon. Malaking problema pag nag-memorize ka. Kasi napakalaki ng chance na makalimutan mo ang formula. Talagang gusto ko talaga analyze. Why do I want you to analyze? Kasi that's the easiest way of doing. Analyzing is easier and it will you will be able to practice yung circuit analysis instead of just memorizing. Baka pag binigyan ka na ng ibang circuit, hindi ka na makasagot. Dinagdagan lang ng resistor, hindi na makasagot. Okay? So, this one is yung example para dyan sa fixed bias. You simply plug in. The answers are here already. Now, I just want to emphasize this one. Direct substitution lang naman dun sa mga formula na yon. Normally, pagka binigyan ka, kunwari test, and then ang test ay, let's say, nasa classroom tayo nagte-test. Normally, ang unang mong ginagawa, nag-a-analyze ka muna. Gagawin mo muna to. Tapos, tsaka ka magko-compute. Okay? Tsaka mo na ipa-plug in yung mga numbers na yan. Okay? Now, I just want to emphasize this one. Ang hinahanap kasi sa iyo is VBC. Remember, this one is an NPN. You have here a plus, you have a minus. For the VBE, ang VCE naman is plus minus like this one. Ang VCB, kaya as I said a while ago, you take note of how I said it. This is VCB. You call it as VCB because collector to base, voltage across the collector base, junction. Ang tinatanong sa inyo ay VBC dito. So, you have your formula na VCE is equal to VCB na plus VBE. So, ang gawin nyo muna, hanapin nyo na lang muna yung VCB. Ganyan, Tapos, pag may sagot na kayo, let's say, pagka tinanong kasi sa'yo, VCB, ang magiging sagot mo dito, VCB ay 6.13 volts. Assuming that we are already done with all of these things, ano? So, pag VBC itinanong, gawin mo lang na negative, ano? VBC now is equal to negative 6.13. Bakit siya negative? Kasi your base is here, this is negative, plus. Ano? So, with respect to, ano, base, ano? So, it is from base to collector. Now, take note of that, ha? 6.13 volts rin siya. Kanya lang, sa polarity na sila nagkaiba. Ano? And please remember that 6.13 volts and negative 6.13 volts, they have the same amplitude. Parehas lang yan. Hindi yan kagaya ng numero sa ano natin, sa number line, ano, na pagka negative, less, hindi. Parehas lang silang dalawa, no, ng amplitude. Nagkaiba lang ay ang polarity. Okay? So, yan. So, ito lang yung gusto kong i-emphasize. Na? Now, of course, ito, kagaya nito, there is another one. The VB, tingnan mo yung circuit mo, ano ba yung VB? Simula, pagka single subscript, ano sinabi? Pag single subscript, sinabing base, VB, it is from base to ground. And nakita mo naman, from base to ground, wala namang resistor dito. So, ibig sabihin, from base up to ground, VBE lang siya. Kagaya nito, VC, single subscript. Oh, that's why the answer here for VBE is 0.7 volt. Ano? Sa VC naman, tingnan natin, nasan ang collector? O itong collector, single subscript. Ibig sabihin ng single subscript, ano? VC to ground. Ano? Hanggang dyan. So, makikita mo, wala namang resistor dito. Wala na namang ibang circuit pa na component. So, ibig sabihin, the VCE for this the VC for this particular circuit is just the same as the VCE. Kaya kung mapapansin mo, ito yung VCE. Ito yung VC, ano? Ito yung VCE. Na? Sunod-sunod lang yan, ano? Ito yung answer para sa IBQ. You just plug in it in the formula. This is the answer for ICQ, and this is for the VCEQ. So, itong VCEQ dito, parehas lang dito, simply because of this circuit. From collector up to ground, you do not have any components anymore. Okay? So, be very observant, dun sa circuit, Okay. And then, we have the emitter stabilized bias circuit. Let's see, ano lang yung difference? You can do this, ano lang ang difference? Sige, you tell me, what's the difference between the fixed bias and the emitter stabilized? Observe.
May resistor.
Yes, resistor where?
Sa may emitter po.
Sa emitter. Okay, yun lang yung difference. So, ibig sabihin, our analysis here is still applicable, except that you are going to add na on your analysis, yung ito, para sa RE. Do you have a class after this?
Meron po.
Oh, meron na. Okay. So, okay. We'll continue this on Friday. Or we will meet again on Friday, okay?
Opo.
Okay. Wait lang. Hold on. Okay, yung mga, 28 lang kayo ang unti nyo. Yung mga hindi pa nag-chat, please chat. Brennan Ocampo? He is available pero he is absent. Oh, wala siya dito. Okay, yung mga hindi pa nag-chat, chat muna ng good afternoon or whatever, before we go, we will be meeting again on Friday, and then I'll think about your quiz, how we're going to do that, Pero ang sigurado, we have lecture on Friday and lecture on Wednesday. Okay? You practice on the emitter stabilized, how you anong tawag dito, on how you derive the formula, ano? But then I will still be discussing that next meeting. Okay? God bless.
Thank you po.
Thank you, Ren. Sige, you can
Thank
go
you,
to
ma'am.
the next class. Yes. Brennan. Brennan. Brennan Ocampo.
Hello po, ma'am. Sorry po,
Oh.
na-DC lang. Na-DC lang po. Kanina pa po ako nakakonect.
Nakakonect ka dito kanina?
Opo, opo.
You were able, para kasi dito lang kita nakita sa baba eh.
Ay, hindi po. Kanina pa po ako. Mga 12:42 po, ganun.
Siya,
Kaya
sige,
po ako
sige.
nakapag-good afternoon. Sorry po, ma'am. Sorry po.
Okay, okay. O, sige, God bless. Bye.
Thank you po, bye po.